When limits of functions do not exist, redefining it may find a continuity. Check how to redefine a limit here in differential calculus. The first function to find the limit with is the root of x plus 1 less 2 all over x. First is to identify the point of discontinuity. Looking for the discontinuity on a rational function is easy, as one only needs to check on the denominator. Why is this? It is because any numerator divided by 0 turns the whole limit as undefined. Thus, for now, the limit doesn't exist. Although later on, there are calculus methods in figuring out indeterminate forms. So going back to the problem, the denominator is x, and x must not be equal to 0, as it will create an undefined function. Learning that the point of discontinuity is 0, substitute this value into the function, making f of x as the root of 0 plus 1 minus 2 upon 0. This turns out as 1 minus 2 over 0, and this is then undefined. Now let's attempt to redefine the function. By redefine, we meant looking for continuity at x of 0. Relative to the character of the function, we use conjugate and multiply root of x plus 1 plus 2 over the same. This is done in order to create sum and difference of two terms. This is then eventually condensed into difference of two squares, producing the square of the root of x plus 1 minus the square of 2. The denominator also becomes x times the binomial root of x plus 1 plus 2. F of x then has the numerator simplified as x plus 1 minus 4. Take the limit of this function, with x approaching 0. The limit turns out as 0 minus 3 all upon 0 times the root of 1 plus 2. This results to negative 3 over 0, which is still undefined. Thus, we can say that the limit doesn't exist. The other example includes f of x as the root of x plus 4 minus 2 all over x. Again, identify the point of discontinuity, and just the same, the denominator showing x must not be 0. Now substitute 0 for x, creating f of x as the root of 0 plus 4 minus 2 over 0, resulting to 2 minus 2 over 0, which is then 0 over 0, an indeterminate form. After knowing that we cannot use substitution, we redefine the function by using conjugate. The function is then multiplied by the root of x plus 4 plus 2 over the same, creating sum and difference of two terms. The numerator is then simplified, becoming the square of the root of x plus 4 less the square of 2, and this is known as difference of two squares. F of x then turns into x plus 4 minus 4 upon x times the binomial root of x plus 4 plus 2. 4 minus 4 is 0, and x cancels out, creating f of x as 1 upon the root of x plus 4 plus 2. Now take the limit of this function as x approaches 0, resulting to 1 over the root of 0 plus 4 plus 2, which makes 1/4. This is the redefined limit. Another problem is x squared plus 5x plus 4 upon x plus 4. The discontinuity for this function lies at the denominator, x plus 4, where x should not be equal to negative 4. By substituting this value into f of x, we get the square of negative 4 plus 5 of negative 4 plus 4 all upon negative 4 plus 4. The numerator then becomes 16 minus 20 plus 4, which is then simplified as 0 over 0, making the function indeterminate. Now redefine this function to find continuity, and this is through factoring. The numerator of the function is then expanded as x plus 4 times x plus 1, where x plus 4 cancels out with the denominator, leaving f of x as x plus 1. Take the limit of this function as x approaches negative 4, which then becomes negative 4 plus 1. So the redefined limit is negative 3.